funny, bro.
It's the memes, bro. It's just I'm good for the memes.
You probably have sugar daddy, like the lollipops. I will take.
Yeah, thank you, my niece.
Oh, cute.
Yesterday.
What's her costume?
One day you're gonna.
Which, you want the?
I'm sure already answered.
I was being high school, but that has to be on.
We did her makeup and she has like a little broom too.
They bear you up.
Oh,
We're on the brink store. I'm probably gonna die.
I know, I'm putting that
Bro,
on the. I'm not right.
I'm backstage.
Always, bro. This is cool, like, hey, no, this is like,
I love it.
okay, it is working.
That's it.
Yeah, I have no control.
$4 grand anything.
Like,
Okay, guys, my dedicated students. Scan the QR code.
Already did, I'm way ahead of you.
I know, but the rest didn't.
How do you know? So, there's a attendance?
Yeah.
Oh, I have a question. I need to get the roster from you get a roster here?
Yes, that's how I can send the weekly emails.
No, like the sign it like.
Oh,
not the roster
to sign it?
for class,
No.
but, like the roster of everybody that signed in.
No, I did last semester.
Cause so one student, they need, so the professor's going like, oh, if you attended any extra resources, we're gonna give you extra credit. We're gonna give you the roster. So then I gotta get. the
Oh,
roster.
yeah.
So, I wanna help these guys.
No, yeah. It's like they need, especially for physics. Exactly.
Yeah.
I'm trying to, that's the only reason they pull up. Well, someone just sit there on their phone.
Right here.
Where's the spider web? Oh, there we go. Okay, so we all want to start with the spider web before we do practice problems?
Oh, did you post this? No, you said. so.
No, I did not, because I'm posting it with the answer key. It should be the exact same one as last time.
So just mark it.
There we go.
Do you think you could switch the yellow ones for like something? You know what?
Yeah, I want to switch it. So yeah. I can just write over it, so it's clear to see. But yeah, you guys can see it, never mind.
That's HCN, right? So that's HCN, the two alcohol groups, and then the cyanide there.
Yes,
That's
this
CN.
is your little cyanhydrin information. Okay. Well, I was explaining the spider web. Who got the gist of it? Did we all get the gist of it? Or we were confused about it? It's okay, you guys can be honest.
We understand just like practical problem. In the sense that like, is he gonna ask us about the transition stage or like process, or is he gonna give us like a reagent and ABC, figure out which one is the answer?
Yeah, the only parts that you have to memorize is just reagent, final product, that's it.
Okay.
Two we totally just do like.
We're gonna do the practice problems in here, actually.
Make that.
So let's do those. You guys should know this portion. So.
It's one day, that's
No, so I'm just saying, wait, the only thing I remember is the means. Where.
Imines.
Yeah.
Yes, but we're not talking about imines right now. We're talking about carbonyls and their reactivity.
This
We
is
talked
15,
about those
we're talking about
16. We talked about them on chapter 12, if I remember correctly. But how do we know that something is really, really reactive as far as
So we
carbonyls
do
go?
between, so it's between inductive effect and resonance, right? And
Mhm.
electronegativity, which is inductive effect.
So which one of those functional groups is gonna be the most reactive? And actually, let's start with the names first, just to see if you guys know this one. What's the name of that one?
Amide.
Amide?
Oh,
Man,
okay,
man.
yeah. That was the shot in the
The
dark.
second one.
What would happen if it's amine? How does it look like?
The double bond nitrogen?
No, just the N.
Just nitrogen with pure single bonds, exactly.
Oh, I guess, okay.
What about that one?
Ketone.
Exactly. This is your
Okay.
dear ketone, corsic acid. Aldehyde.
No, there's a specific name for that, that's acetone, right?
Then-
Acetone is this one. It's a
Oh.
ketone.
No, okay, so then this one is acetic acid.
Acetic acid. It's gonna be an ester of some
No, not
sort,
this one,
but I forgot.
that one, the
Carboxylic acid.
You said what?
Carboxylic acid?
Yeah, but is that
Specific,
common
is
name?
that a,
That's the name of the functional group.
No, I understand that, but I'm saying, what was like the common name for it? There is a common, is it acetic acid?
so like a one methyl, carbon, carboxylic acid is referred to as what?
Cause it's.
Ethanoic acid. There we go.
Ethanoic acid?
Yes.
Oh, okay, there it is.
Ethanoic acid.
Ethanoic. He's not gonna be asking for you that name, so don't worry.
Oh,
What about that one? What's the name?
an ester or like
Thank you. Yes. How does an ether look like
without the carbonyl?
without the carbonyl? Yes. Okay, now we have our functional groups. Which one is more reactive and why?
Aldehyde is the most reactive, so steric hindrance.
Yes, exactly. Remember, if you don't have that much steric hindrance, it's easier to attack you. So that's why your aldehyde is the most reactive. What's the second one?
Ketone.
Beautiful. Okay, so we have those out. What about those three?
But the least reactive is the amide,
Ethanoic acid.
and then,
After ketone.
okay, so it goes carboxylic acid, ester, amide.
Yes.
Yeah.
Carboxylic
Ester,
acid.
amide just because of that.
Process.
Am I?
I get that.
Okay. Questions. And we're gonna add a few more functional groups on chapter 17, actually. Okay, but the trend is the same.
What were the functions?
The new ones, they're gonna be acetic anhydride, thioester, and acyl halide.
Radical.
Nope, they're for chapter 17.
Okay, then.
Yes. You don't have to worry about it right now, but for the exam, yes, you do.
Wait, so for this exam, we're
So yes, because this exam should be 15, 16, 17. So 3 chapters. Okay, let's practice. Okay, we're gonna wait a few seconds before we just spit out the answer. Okay, what's the name of this guy? Nope. What's the name? Hydrazine. Is that a reagent or a product? Beautiful. What about this guy? Remember, we have to know the names. Hydrazone. And this is the product. What about this one? Beautiful, phenylhydrazine. What about that one?
Then amine.
What kind of amine? Primary amine. What about this guy on the right?
Tertiary amine.
That's kind of double bond there.
Which one? No,
It's an amine for a fact.
it had a funny name. That's when everyone started laughing.
You mean?
Anamine, exactly. Your dear enemy. What's the name of that little guy?
Acetic acid.
No. What do we think?
Hydrazole.
No, and actually you were the closest one of getting this name last session. I mean, yeah, with this reagent, you're gonna create the oxime. How do we go? Which one? No,
And the answer is,
hydroxylamine. Hydroxyl because of the alcohol, and it's two is your amine. And actually, I'm not sure if I showed you this name, so sorry. Okay, this one. Should we say
Hydroxyl.
no, it's a enemy.
oxime? What about this one?
Phenylamine.
Phenylhydramine. Mean.
Which one? No,
Phenylhydrazine.
change something.
Phenylhydrazine.
There you go. What about that little molecule? Hydrostone, because it was a product.
Is this the imine?
Cause there's a what?
Imine.
Wait, why is it zone and not?
Oh, remember, that's telling you that it's a product. If it's in, it's the reagent. We're gonna see practice problems. Don't worry about it, Sam. Don't worry about it. Okay, this one should be pretty simple. What's the name?
Yeah.
Gem.
It's a ketol. Acetyl little.
You were good with the gem portion.
Yeah. Gem.
Gem dial.
Gem dial.
Gem dial.
Thank you.
Set first.
Good job, Kayla. This one. And actually, this last four are very important because you're gonna get a few questions asking which of the following is an acetyl, which one is a hem.
Ketal, ketal. No,
Gem ketol.
Which one?
Yes.
Hemiacetal, exactly. The arms don't match up, and we see that in the legs we have one hydrogen. So hemiacetal. What about this one?
Gem. Acid.
It's the acetal. Because this time the arms match up with each other. And in the legs, we can see that we have one hydrogen, so that it means that it came from an aldehyde. Now, similar process over here. What's this guy?
Ketol.
Beautiful.
Wait. Oh, it's just the insertion of the second or.
What about the last one? Beautiful. Okay. Questions on identifying those names. It's all zoomed out.
What's that, second one from the left, second one in the right?
Hydroxylamine,
No, second one from the left, next to that.
oxime.
Oxime.
Dial. Yeah, I really have to fix my handwriting. It's a problem. Thank you.
It's not bad, Hannah. That's like cursive. It looks good.
It's not supposed to be cursive.
I've seen PhDs. get way worse.
Yeah, probably mine's gonna get worse.
Like when the doctor prescribes paracetamol, you can tell.
No,
it's
yeah.
good, but it's
I
like,
think they just stopped caring.
Then it's just a scribble.
yeah.
Like, you get it,
Okay, are we good? Are you ready to start the practice problems?
yes.
Okay, let's do. Okay, let's start simple with this one. Okay, First of all, what kind of functional group are we starting with?
Um,
Aldehyde, beautiful. Okay, we have an aldehyde. We have this guy. What kind of reagent is that?
Alcohol.
Alcohols can be acids or bases. So yeah, but it's an alcohol group. So what are we gonna form?
Alcohol group.
No, a hemi,
Oh, that's
hemi
what, okay.
ketone? No, hemi acid.
What catalyst do we have? Acid or base?
Acid.
Acid. Remember, acids, they're gonna give you the full form. Bases are gonna stop at the hemi form.
Oh, where you add the two hydroxyl.
Okay, so it's
To
just
the-
a gendiol, you're gonna have a gendiol.
No, Gem Dial was with two R groups. This was
Right,
a
right, so you're
Gem,
missing an
No,
R.
no, no.
Okay, so why don't you go ahead?
Gem acid.
What's the name? Kayla. What are we gonna form? That's okay, Kayla. That's okay. It's a Monday. It's rough. Okay, so this one, it's an alcohol group.
Just stay up, yeah. Oh,
This one, we have an alcohol group in here. Because it's an acid, we're either gonna create the keto or the acetyl, depending on what we have. We had an aldehyde, so that means we're
So go
creating,
back to the chart, just so I can see that again. So-
yes,
So right, it's an acid with the ROH, which is what we have,
yes,
and we have acid. Oh, so it's not like a diol, it's gonna be the R groups.
mhm.
Okay,
wait, I'm looking at the difference between the base. Yeah.
So the acid is the one that creates the full form. For bases, we're creating the hemi form.
Why aren't you adding an OH? The acid form.
In the
You're
acid form, that's intermediate. In the intermediate, we're gonna have an alcohol group, but at the end, we're gonna repeat the whole process again, and that's how we end up with just pure ethers. Okay, let's go back. Okay, so what was the shortcut?
adding the top. Then you add the arms.
Exactly. So that means that the legs are gonna remain the exact same. And then we have 1 and 2 arms. What are gonna go in those arms?
One OR and another, two ORs. It's nasty.
Okay, now, the R portion, that's just specific to that reagent that you have. How many carbons am I gonna add in there?
One.
1, beautiful. And there we go, that's it.
so this is not too bad.
It's not
Like, when
bad.
you, when you don't,
Memorize it.
if you take away the steps involved in the electron movement. of the
Yes.
reaction, that's,
And you start to understand it honestly after a while, like.
It starts squeaking, yeah.
Okay, so you're cleaving and you're adding two NH2 to the nest.
Oh, we're doing the second one, okay.
Yeah.
What's the name of the
Should I-
reagent? What's the name of the reagent for this one?
I just,
Hydrazine.
okay.
So we're gonna create the hydrazone. Walk me through the shortcut.
The top, add two arms with the NH2,
Are you gonna add 2 arms in here?
one arm with NH2 and one arm with H.
Do you agree?
I was. Yeah.
Okay, let's go back to our little spider web. So we have our dear hydrazine, right? Okay,
Oh, it's double bond.
it's double bonded. So in this case, our Frankenstein is keeping basically the same structure. We're just switching the heads, and that's it. So from the reagent, you're just taking away some hydrogens from the lesserly hindered nitrogen, and then from this nitrogen, that's gonna be the one replacing your oxygen.
Wait, NH2 is double bonded?
Yeah, so if you go back to the.
In the reagent, no. But in the product, we're gonna want that nitrogen to be double bonded,
No, I'm talking about like in the reagent, is it?
No,
the two
single
NH2,
bond.
They're single bond,
single bond.
so in the reagent, the H is going to the double bond where, what?
So the hydrogens from the reagent, they're gonna go away. So that means that you have some electrons left over for that nitrogen. So that's how we're gonna create that double bond.
So both the hydrogens go away and.
Yeah.
Two bonds are replaced. Okay.
Okay, so if we go here now, instead of drawing our arms, we're gonna keep the little head, double bond. In this case, does it matter which one I cleave of those nitrogens?
No.
No. So let's just do the left one because why not? And NH2.
Is this one the one of those where you can also catalyze with a base?
Yes.
Okay.
So remember, the only special ones were your acetyl or keto creations. For the rest of them, we can have acid or base or maybe even no catalyst.
And we said that's because the base makes it more nucleophilic.
Mm-hmm,
And then
exactly.
the acid makes it
More electrophilic. There you go. Now, in this case, we have a double bond. Could we have E and C isomers?
Yes.
Okay, for that one, what's the form that we have? E or C?
C. No, I'm sorry.
E.
Transit E. Transit E. yes.
It's E. So yeah, this is your major group. That's your other major group. This one's E. So you're also gonna get the C isomer as well. Okay, so keep that in mind. Okay, questions so far? We're good?
Would you get one preference to the E, I mean, more preference to the E? Or would it
Yes, because
be-
overall it's less circle hinder, so yeah.
And that is across all reactions, right? Where it prefers the
Yes,
E.
in general, you always want something that's really, really stable. So yeah, that includes E and C isomers. Mm-hmm. Okay, let's give it a try.
So yeah, you cleave the O, but it keeps the double bond at the end.
Yes.
And then whatever substituents off the end, that's gonna be, so it's one carbon. So it's just a double bonded end with the carbon off of the end.
Yes, and what's the name of that product? You are correct.
Imine. Okay.
Imine. So what reagent do we have?
Primary.
Primary amine. That's how we know that we're forming the imine. Again, we chop off the head, keep the legs. And then we're just swapping up our head. So we have a nitrogen, we get rid of those hydrogens and the reagent. And then we just connect one little methyl group. In that case, can I create E and C isomers?
Negative.
No, because we have symmetry in there.
That's an imine.
Imine. This
I-
guy.
I-
Imine. This guy was your hydrostone.
When you're taking evolution.
Okay, this one. Name of the reagent. Beautiful. Phenylhydrazine. So same shortcut. Chop off the head, keep the legs. And then we're basically just gonna switch up that head in there. So now, which nitrogen am I gonna cleave, left or right?
Left there.
Exactly. So this nitrogen is connected to NH. And then my benzene group. Okay, can I create isomers in here?
Yes.
Yes. What's the configuration of that one?
So this one's gonna be. Oh, that's a good one.
Is it E or C?
Wait a minute, but there's no fourth substituent, right? Oh, no, but it's still locked in that place. So then
Exactly.
This one's gonna always be E, right? Just naturality. Set E is-
Exactly. This one it's E, and you're also creating the C isomer, but it's minor. And your product is just called your phenylhydrazone. That's it. Questions on that one? Very simple. So far, we're feeling good with this chapter. Yes, we are. Volunteers. Who wants to do the next one? Okay, Sam, you get the first one, and then you can choose. Go for it. Like 80% correct.
It's actually like that spider web is what, like, it's crazy.
What are you trying to form? What's the name? Oh, wait, I can see. No, that's the same thing, that same right there. Why did you draw it like that? One.
Spider web. It's wait.
And he's referring to the sheet, he said it's just
Yeah.
with the sheet.
It's just because of the spider web. But what are you forming? What's the name?
And so,
Funny one.
Enemy.
Enemy. It's the enemy. That's your funny guy. What were the rules for that reaction? That was the only special one. Yes. But yeah, remember the enemy was the only funky one because the double bond is not between heteroatoms. It's pure carbons. So that's the main difference. And then also look at the reagent. What kind of amine is that? Primary, secondary, tertiary? Secondary. Secondary amines are always going to give you the enamine. Primary ones give you the imine. Mhm.
so the enamine is just a double bond in the beta position of the nitrogen.
Yes. Questions so
I'll go
far?
for the next.
Does it matter how many R groups there are around it? Or it's just.
No, but what was the only requirement? What was the only requirement for this reaction?
Can be tertiary.
And yeah, that's one of them. But what about that initial molecule? What do we need to have in there? We don't have carbonic acid at all.
Carbonyl.
No. It was something about a specific position. Look at the spider web. There are some notes in that reaction. What does it say?
Oh, that's blurred out.
Anyone else who can read the spider web? What does it say? What's the requirement?
Look at the spider web.
And weights.
What about over here? Do we have the spider web? Okay, what are the notes that you have for the enamine? Wait. Which kind of hydrogens? What's the name? It says it right there.
Beta hydrogen.
Well, alpha hydrogens. Thank you, Kayla. And then remember, we always want the most stable product, so that's why we're choosing the one on the right instead of the left. We have alpha hydrogens on both carbons, left and right. But we're choosing the right one because that's more stable. Okay, on to the next one.
Why is it more stable if it's closer to more carbon?
What's the rule for stability of double bonds? Besides E and C.
Oh, yeah, it can't be general. I mean, it can't be like at the end of a thing.
That too, and also you want the most R groups. Exactly. And great job on, what's the name?
Enamine.
Emi.
Imine,
Amine.
because we're starting with the primary one.
That's
Okay, Juan, choose your volunteer.
Who wants it?
Let's be careful.
Raise your hand.
You don't have to show me the mechanism. Just show me the shortcut and the product. Partially correct. What happens if we have X's?
Is it like the double bond thing, makes double tax two hands?
So yes, in this case, we're gonna repeat the whole process. So on the other end of that nitrogen that's hanging, instead of having hydrogens, you have that ketone connect to it.
Oh, because of the inductive effect of both electrons, so it makes it positive.
So erase those hydrogens, those H2,
You know what it says?
and
Oh,
then
you have
draw
double
the same
bond.
exact thing. There you go. That's it. Great job.
Oh.
Exactly. Geraldine, you can choose your bond.
Because it becomes a reagent in a way.
Choose
So
anyone
it-
you
it
want.
Starts,
Okay.
ketone and the N2, H2, right? And then that piece reacts again.
Really bored.
Instead of
Oh
one-
God, yeah. It's supposed to say oxide. Yes, it's just really, really blurry. You're gonna create your oxide, which looks like beautiful. And can you create ENC isomers? Yes. What's the conformation of that one? Beautiful. So we're also going to create minor product, the C one. And that's it. Great job. Abigail, choose your volunteer. Okay, Kayla. We're going to create our enemy. What was the requirement for that reaction? No. You need what kind of hydrogens? Alpha hydrogens. So what's going to happen? No reaction. Simple as that. You got the easy one. If there are no alpha hydrogens, I love that.
Bodies.
Exactly. Okay, Kayla, choose your volunteer. Oh, Geraldine. The reaction just cannot proceed. If you had an amine, a primary amine instead, then yeah. Kayla, choose your volunteer. Okay, we're bringing it back. Okay, you're keeping the legs. You're making arms.
Wait. With the acid though, so you're
So-
making,
What does that mean? What do you create? The hemiform or the full form?
Yeah.
no, no.
You're missing one carbon, yes.
Actually, two.
Yeah. We could,
Oh,
Exactly.
there you go. Beautiful. What's the name of that guy? We should know them. We have to know them for the exam.
Gem dot.
Mm.
Hemi.
Mm.
no, so,
It's a keto. Exactly. Sam,
Dial.
Abigail. They are just from the carbon chain in that alcohol group in your reagent. You have 1 and 2. Mhm. Sam, choose your volunteer.
I volunteer myself.
We cannot volunteer ourselves.
Volunteer myself as tribute.
No.
I'll pass it to Tom and Don.
That OH gets split into these two O's, or that gets split into two O's. And then the
So one of them is coming from the ketone, the other one is coming from the reagent. Oops, sorry.
I learned a lot about bicycles.
Okay, yeah, about that.
Just ate, god damn it.
What do you mean? Because sometimes you can eat a big meal, but if you don't have enough carbs, you get the
Yeah, I didn't have enough carbs. You're right.
basic, you need it. I got
I
that.
got enough carbs.
You can be full, okay, but still, that's just, that's actually the ketosis. You reduce ketosis because your body's breaking down with it.
Yes,
No, I didn't have some.
that's right.
Which makes you urine more sick. Also, a sign of diabetes.
Basically, for. I actually don't think.
Great
it's
for
a
every
react-
Why?
Because it's the secondary amines, so that means the double bond is like, it's not on the nitrogen, it's next to it, but it can't go through the bonds.
Why not? What happens?
Because one of the one is the thing, and the other one is the hydrogen.
Exactly. So we don't have any alpha hydrogens available, so it's just no reaction. Simple as that. And actually, what's your name? I always see you in a slide, but I don't know your name. Yours? Jerson. Nice to meet you, Jerson. Choose your volunteer. No reaction.
Because no beta had, no.
Alpha. Alpha.
Wait, there is no hydrogen, what?
There's no alpha hydrogen.
Yes, there is, right there.
No.
I told you guys that hydrogen from the aldehyde is not considered an alpha hydrogen.
So it's alpha to where the carbonyl ends. So not on the carbon that holds the carbonyl,
No.
okay.
It's on the carbon
essentially
adjacent.
beta from the carbonyl.
Yeah. Okay. Choose your volunteer. Whoever you want.
Okay.
Sure.
But we don't have that many people today, so we have to repeat them. Why did he cancel it? Did he say? Oh, no idea. Like, I didn't even know that he canceled class until like a few hours ago. So, yeah.
It must have been
Well, it's pretty much the same.
I was already on campus.
on this project.
Yeah, he has a current project right now. He just, I think, sent an abstract or something like that. He wrote a proposal.
Wait, tell me,
Oh, that's from what he said in lecture. I just listened to him. Oh, no. I can ask your TA, but it is. It is very interesting.
How's that?
And great job, Juan. What's the name of that guy?
And you were gonna ask me that, and I was just thinking about it, and.
Come on, you know it. Don't say it, Sam. Don't say it.
Amy.
no.
Don't say it.
Enemy.
Yes, funny one. It's your enemy.
It was one of the two funnies.
Yes.
So funny.
Okay. Yeah, sure, why not?
Big dog in the back, you want this? Right, you wanna try it? No, you chilling?
We're just chilling.
I'm just gonna pass.
One of the girls, Abigail, your turn.
Is for the isomers, stereochemistry.
I would love to be involved with you.
I know you. You already got it. So you would, no, everything's possible. We can do new shit.
I might do that.
Oh, what's that? Really good.
Beautiful, you're creating your hydro zone.
It's fun.
Beautiful. Can we create isomers? So yes, that's the E form, and we can also create the C form. Great job, Abigail. Choose whoever you want.
Take one down, pass it around. There's a lot of examples, that's good though.
Times go fast when you're having fun.
There's no catalyst,
So what happens?
it goes slow.
It goes slow, yes. So what are you gonna form? What's the name of the product?
Dial? No.
No.
Single. Emmy keto.
Yes, you got it. It's the hemiketo.
It's just clicking now.
Wait. And what's the acid that?
Hemiacetal.
There's one-
Same thing on the arms, but the legs are
There's the
different.
H. There's
Exactly.
the H one, yeah.
Mm-hmm.
H is for the high.
And one more carbon. One more carbon, Lisa. There you go. Great job. Okay. Kayla, you go. Okay, we're drawing it. Oh my God, my brother does the same thing. He is always saying it at home.
Wait, is there a preference to which OH and which OR goes on where? Because technically.
Not really. Single bonds constantly rotate,
Oh, I see.
So, it doesn't really matter.
But in
Bless
theory,
you.
shouldn't the OR be like E to the larger R group?
No, we can have E or C
No,
in
no,
this
she's-
case.
I mean,
But yeah,
gravity
you
is-
should draw it on the left side. We are gonna form chiral centers, yes, RNS. But there's no really preference over
Yeah, we're not.
why one's sad and why one's happy. Oh, what's the name of that product, Kayla? Oxime, beautiful. Like a cow?
Oh,
Never mind.
It's
oh,
okay.
yeah.
Like oxen and bovine are both cows. What the fuck is it?
What are you saying?
No,
It's Monday. We're okay. It's Monday.
I got it.
Scroll up, I have to see. See the. Yeah, there you
Oh,
go.
Bovine, BOVINE.
There you go.
Related to or affecting cattle, so bovine tuberculosis.
Oh, see? That.
That or keep going the other side.
It can go on either side, exactly. We have symmetry, it doesn't really matter. What's the name of that product?
And I mean,
And I mean, the funny one. Choose your volunteer. It can be anyone you want. You can choose them. They don't have to volunteer. Want to give it a try for one of the products? Want to give it a try? Want to try one of those reactions? Like to show me? Very good. Maybe we can help her out at the same time. Sam, help her out. Which O? In the ketone.
Wait a minute, is this the one where it's like no reaction?
oh, you're right. It is no reaction.
Why?
Because there's no alpha hydrogens on the.
Beautiful. No alpha hydrogen, simple as that. No reaction. So,
Do the next one, do the next word.
Yeah, I'm sorry, that's. I feel so bad.
Like, let's not say the answer, let's just guide her
Yeah.
through it.
2 minutes.
Okay, there are the legs. That's the start of the head. I know what's gonna be your new head. Nitrogen. And great job. What's the name of that one?
Same problem of 4 times.
I think so.
Actually, the third time we got that same. At least 6 times. The other one said X.
Oh, God.
This one doesn't say X.
See, there's a subtle difference, but there is a difference. Real quickly, what's the name of that guy that we just created? No,
Hydrogen. So,
zone.
I'm gonna get this, bro. I'm gonna study.
And
It's
that's
not that
it.
chapter. It's not.
Simple as that. Chapter 16 is not too bad. Just memorize the spider web. Yes,
But right now,
since we're already finished. Yeah, it can be posted right now.
I got e-tutoring right now, so I gotta do that, and a lot of people don't show up, so I'm gonna study this.
That's good. And if you didn't sign that QR code, just do it real quickly right now.
Catch the flag, sir.
16 is just gonna be like this question.
Mm-hmm.
Notice it.
Just that. Not too bad.
So.
I told you guys it's gonna get easier as we move through the chapters.
I subbutyl aluminum. I don't.
Okay, guys, I'll see you Wednesday.
Being in a lobby with you.
Let's see, let's post this.
No.